Hi friends, welcome back to my channel, and today I'm going to explain you a very important DP problem, point change. So here you are given an integer array coins representing coins of different denominations and an integer amount representing a total number of money. So what is given? Like uh, a number of coins, an array of coins of different denominations, like a coin of denomination 1, coin of denomination 2, and coin of denomination 5. Okay. And one amount is given. Okay. Return the fewest number of coins that you need to make up that amount. Okay. We need to return the fewest number of coins. Okay. By taking how many? See, uh, we can take like 11 1, and we can make up this amount 11, right? We can also take like 5 2, then 1 1. Okay, so we can also take like 5 5 and 1. So here the number minimum, like only 3 coins we need to take here. So that's what we are going to return, like the fewest number of coins that we need to make up that amount. Okay. If that amount of money cannot be made by any combination of the coin. Okay, let's take this case. Okay, if it can't be made, then we'll return -1. Okay, you may assume that you have an infinite number of each kind of coin. Okay, like as many number of ones we need, we can take. Okay, as many numbers of coins of denomination 2 need, we can take, and same for 5 as well. Okay, so let's see how we can approach this problem and solve it. Okay, so what we'll try, we will try different approaches. Okay, like here obviously we are, since it is, we need to find all the possible ways, and and find the minimum out of it. So that's why obviously we're going to use recursion here, and finally um, we're we'll be optimizing it, and we'll use the DP. Okay. So here, what we can do to make the amount 11, right? We can take one. We can take one here, right? If we take one, okay, then what will happen? The amount left is 10. If we take two, the amount left is 9. If we take 5, the amount left is 6. Okay. So this is one way. So here, if you see here, if we take one here, then here we are, our count will be one here, right? Our count will be one here. Again, suppose if we take one here, f of 9, and f of 8 here, and f of, uh, you can say 10, 5, 5 here. So in each branch, right, different ways are possible, and each function call, okay, will um keep increasing the like 1 1, okay, the count 1 1, and we'll find the minimum out it. For example, see here. Suppose first we will try with F10, then we'll try with F9, then we'll try with first we'll take F6. So which is minimum out of these three ways that we need to find? Okay. So instead of directly returning this one, what we'll do is we will make one plus again one method call. Okay. And here also one plus again one method call. Okay, this recursion call and one plus here. And we'll find the minimum of it. Okay. And we'll add one here and we'll return. Okay. Yeah, let's code it. So first I'll declare one. First I'll go with the brute force approach. That means just a brute force recursive solution. So first I'll declare one variable called inf. Okay, private static final in inf equal to. Since I need to find the minimum, right? So that's why I'm putting the maximum value. And here I'm making by 2. I'll tell you later why I'm doing this. And yeah, so result equal to I'll make one DFS call here. In this DFS call, I will pass the points and the amount. Okay. You see that function call, right? So this is that function call f of 11. Okay. Now, okay. So if we do like that, right? So what will be the base case here? If you keep doing like this, what will be the base case here? It will come like 9, 8, 7, and finally it will come 0, right? And suppose we'll take 2 here, right? Then if we keep subtracting 2, 2, 2, 2, then finally 1 will left, and again if we subtract 2, then -1 will be returned. Okay. So two base case will be there. Okay. One is 0 and second one is uh, -1. Okay. Like the value can be 0 or -1. So this will be our base case. Okay. So we'll write the condition accordingly. So what we'll do here in this result, okay, in case of like if if it is updated, right? That means definitely the value will be less because we are going to update the minimum only. Okay. If it is not updated, okay, if it is not updated, then there is no such way, right? That will be -1. Okay. So what we'll do, we will return by putting one condition. Okay, here if Rachel is greater than or equal to INM. Okay, if this is the case, then we'll return -1 here. Okay, so there is a chance that this INF can be more than this value because we're adding 1 in each iteration. So this is the possibility. So that's why we're writing greater than equal to INF, and otherwise we'll return the result, which is the minimum value. Okay. Now let's write the recursive method. Private, it will be returning int plus. Then here I'll take the integer array coins and the integer amount. Now, as you see, right? So, what will be the base case? Our amount can be 0 or it can be negative. So, if our amount becomes 0, then we'll return 0. And if our amount is less than 0, then we'll return INF. Now let's come to the actual logic. Okay. So if you see that code, right? If you see that explanation, so here in we are running the function call, the iteration call, the recursive call in for each coin. Okay, this is for coin 1, this is for coin 1, this is for coin 2, this is for coin 5, and we're taking minimum out of all these three. Okay, so how we'll write it? Let's first take one variable called min, and let's assign it inf. Okay, then let's iterate through all the coins. Let's iterate, and for each coin we'll find the we'll have one recursive call. Okay, like feature trace, and we are going to add 1 to all of them. DFS, and what I'll do, I will just subtract first I'll pass the coins here, then I'll subtract coin from the amount. Okay, amount -1. Okay, so I got the result. Now I need to, you know, mm, add 1 and take the minimum of it. So what I'll do, like mean equal to math dot min of min and what, like 1 plus res. Okay, or res plus 1, you can say. And finally, what we'll do, finally we'll return the minimum. Okay, let's run it and try. It is working successfully, but since this is the brute force approach, it will give daily. Okay, it is given daily. Okay, so Now, one thing if you see in our explanation, we have optimal substructure here. Okay. See here we are using F9. Here also we are calculating for F9. Here maybe F5, and going forward here we'll also going to calculate F5. So this repeatedly we are calculating the same problem again and again. Okay. So to avoid that, we will use memoization. Okay. And in memoization, what we'll do, we'll store it in one data structure and we'll check if that value is present, then we'll return. If it is not, then only we'll go and uh, calculate for a particular amount. Okay. So we'll take one memo. Let me take one integer value, integer array, and the variable name is memo, and is the amount will be used as index. Okay, so that's why I am creating an integer array of size amount plus one to avoid the array index out of bounded. Okay, now in this we need to pass this memo here. Also, I need to pass the memo, like I need to receive it, so I need to declare integer there here. Okay. And here also we are calling, so we need to pass the memo here actually. Okay, now here, before calculating this, right? Before calculating this, I'll check in the memo. Okay. So let me fill up the memo first, okay, with the values -2. This array will be filled, okay, uh, -2. Okay, in all the index will -2 will be there. Okay, so now we'll check. If it is not updated, it will be -2. Otherwise, there is some value updated. Okay, so I will check here in the memo. If memo and our index is what amount is not equal to -2, right? So in that case, we'll return the value. Otherwise, what we'll do, otherwise we'll calculate. And finally, before returning the minimum, we'll store that value in the memo. Our index will be amount, and here I'm storing the min. Okay, let's run it now. It is working fine. And also let's submit it. Okay, now you don't see the TLE. Okay, now you don't see the TLE. And okay, this is the completion of the memoization approach. Okay, Now we'll go, or we can say like top-down approach. Okay. Now we'll go with the tabulation approach. Okay. Or bottom-up approach. Okay. So in the tabulation approach, what we'll do, we'll calculate from the amount 0. Okay. And keep calculating by increasing the amount like 0, then 1, we'll calculate for 2, like that. It will go keep calculating and finally we'll reach the destination for the amount 11. Okay. So how can we convert this our recursive code, okay, to tabulation technique or tabulation approach? Okay. Let's see here. So let me declare a dp here, dp, and also let me fill up this dp with infinite. Okay. And in this tabulation approach, we don't consider the the negative scenario. For example, amount is less than 0, right? Here we are returning INF. Okay. So this will not be considered in case of tabulation approach. So let me first fill up this array with INF. Okay. So before that, let me tell you one thing. Why we use integer max value by 2 and not just integer max value? The reason is we are adding here 1. Okay. For some scenarios, this result will be in INF. Okay. Okay. So if it is had it been integer max value, it would have overflowed. Okay. Because we'll keep adding 1, 1, 1, 1 and all, right? So that's why to give headroom, we have just divided it by 2. Okay. So that the overflow will not happen. Okay. Here. Okay. Now let me continue again. Like I just fill up this DP with INM. Then what I'll do, I'll just assign the DP0. Okay. This is for amount 0. What is the value? The value is 0. Now, if it is calculated for 0, now I'll iterate through all the amount. Okay. For int equal to 0. Sorry, 0 is already considered. So let me iterate through 1 from 1. Then the is less than equal to 11. Sorry, amount plus plus. Okay, so I'll iterate through all the amount. Now I also iterate through each coin. For each amount, I'll iterate through each coin, right? So for teacher coins, okay, now I'll iterate it and what logic I'll write. Okay, my logic will be taking the minimum of, let me So I'll keep assigning from the index one, right? So here I'll dp core equal to what will happen? Map dot minimum of what I'll take? Minimum of dp of core and here what we are doing. Mean and res plus one. That means what which logic it contains, like amount minus coin, right? These RESH is associated with amount minus coin. So here what I'll do, dp of here current is our amount CUR. So here what I'll write, core minus what? Coin, right? Amount minus coin. Yes. Here we'll write core minus coin. Okay, cool. And also I am adding one here. Okay, so let me add one here. Okay. Now finally, what we'll do, we'll return the value of TP current. Okay, it will be 11. The final value will be 11. Okay, return. Okay, return DP of core. So we are not going to directly return here, right? Because if the core is updated, then only will return the value of core. If it is not updated, that means if the value is INF, okay, then no, we are just going to return -1, right? If this is greater than or equal to INF, then I'll return -1. Otherwise, I'll return DP of core, right? Let me just remove this unnecessary code which we wrote for the recursion approach. And yeah, let me run it. TP. Okay, sorry. Here it is saying cannot find bar. So what I'll do, amount. Okay, let me get on it. Okay, here index -1 out of bounds for length 12. Okay, so array index out of bound exception is happening here in this line. Okay, this core minus coin. So what we'll do, we'll put a check here. If it is greater than zero, greater than or equal to zero, then only control will come here, otherwise not. So let me put a condition for minus point is greater than equal to zero, then only control will come here. Okay. Yeah, the test case got passed, and now let me submit it. Okay, it is success. All test cases got passed. Now let's go and calculate the time complexity. Okay, so it is running for the this for loop. How many times it will run? It is run the amount of times, and here for each amount, it will run for coins of time. So our time complexity will be amount into points dot length. Okay, and the space complexity will be dp. So it's we can consider as order of amount. Okay, let me write it. Time complexity will be order of amount into coins dot length, and space complexity equal to its order of amount. Okay, yeah, and we're done with the solution. Thank you for watching.